Hi guys, welcome to our channel. Tired of endlessly clicking through the Azure portal just to get a single SQL Server up and running? What if you could do all of that in a fraction of the time with just a few lines of code? I know, deploying a SQL Server on Azure using code can feel like a maze. But stick with me for the next 15 minutes and I'll walk you through deploying your very first Azure SQL VM with Terraform. Best of all, I'll give you all the code you need to do it yourself. To keep our code clean and reusable, we're going to split it into a few different files. In our project folder, we'll make a main.tf for our main resources, a variables.tf to hold our input variables, providers.tf, and an outputs.tf to show us important info after we deploy. This is a common best practice that makes your life a lot easier as your projects get bigger. Now, let's look at the first piece of code in our providers.tf file. This is the provider block. This first Terraform block tells Terraform that we need the Azure provider. That's the plugin that lets Terraform talk to Azure's APIs. I've updated the version to C4.0, which is a recent stable release. The provider AzureRAM block is where you could set things like authentication, but we're keeping it simple. We'll just assume you're already logged in with the Azure CLI. With our provider ready, the very first thing we need is a resource group. You can think of a resource group as just a logical container in Azure that holds all the related pieces of our application. Resource AzureRAM_resource group RG, name Terraform RG, location UAE North. This is our first resource block. We're telling Terraform we want a resource of type AzureRAM_resource group, and we're giving it a local nickname of RG. Inside, we set its name in Azure and the location, which is the Azure region where it will live. This resource group was created in Lesson 1, so as this resource group already exists, so we will use data.AzureRAM_resource group RG, name Terraform RG. Data sources provide dynamic information about entities that are not managed by the current Terraform configuration. When you will use data sources, Terraform will search for an existing resource that has the name you defined in your data source block. A virtual machine can't just float in cyberspace. It needs a network. So next, we'll set up a virtual network, or Vnet, and a subnet for our VM to connect to. As we already created Vnet before in Lesson 2, so we'll use data sources. And remember, as we mentioned before, that data sources provide dynamic information about entities that are not managed by the current Terraform configuration. When you will use data sources, Terraform will search for an existing resource that has the name you defined in your data source block. Data AzureRAM Virtual Network VNet1. Name equals Terraform-VNet1. Resource group name equals data.AzureRAM.resourcegroup.rg.name. Data AzureRAM subnet x0_subnet. Name equals x0. Virtual network name equals data.AzureRAM.virtualnetwork.vnet1.name. Resource group name equals data.AzureRAM.resourcegroup.rg.name. Did you notice how we're referencing the resource group we just defined? We use data.AzureRAM.resourcegroup.rg.name and data.AzureRAM.resourcegroup.rg.location. This is one of Terraform's most powerful features. It automatically understands that the VNet depends on the resource group. Now, our VM needs a network interface card, or NIC, to actually plug into this subnet. Resource AzureRAM Network Interface NIC-VM. Name equals var.nic-name. Location equals data.AzureRAM.resourcegroup.rg.location. Resource group name equals data.AzureRAM.resourcegroup.rg.name. IP configuration, name equals internal, subnet ID equals data.AzureRAM.subnet.x0.id, private IP address allocation equals dynamic. The AzureRAM network interface resource gets created in our resource group and connects to our subnet by referencing its ID. We're setting the private IP to be assigned dynamically just to keep things simple. With the network all set up, it's time for the main event, the virtual machine itself. This is the server that's going to run our SQL instance. First, let's define a variable for our admin password in variables.tf. It's a huge security best practice to never ever hard-code secrets like passwords in your configuration files. Variable admin_password. Description: the admin password for the VM. Type: string, sensitive, true. By setting sensitive equals true, we're telling Terraform not to accidentally show this password in the console output. Now, back in main.tf, let's define the actual VM. Resource: Azure RAM_Windows_virtual machine SQL VM. Name: var.vm.name. Resource group name: data.azureram_resourcegroup.rg. Location: data.azureram_resourcegroup.location. Size: standard_ds2_v2. Admin username: Azure user. Admin password: var.adminpassword. Network interface IDs are azurem_network_interface_vm.id. OS disk, caching, read-write, storage account type, premium_LRS. Source image reference, publisher, Microsoft SQL Server. Offer, SQL 2019, WS 2022. SKU, developer, version, latest. Okay, this is a bigger block, so let's walk through it. We're creating an AzureM_Windows virtual machine and linking it to our resource group and NIC. We give it a size, which determines its CPU and memory, an admin username, and then we reference our password variable using var.adminpassword. The OS disk block defines the main hard drive. But the real magic is in the source image reference block. This is where we tell Azure we don't just want a plain Windows server, we want a special one from the marketplace that comes pre-packaged with SQL Server 2019 Developer Edition on Windows Server 2022. This completely saves us from having to do a manual installation. So now our VM will be created with SQL Server installed, but it isn't fully managed by Azure yet. To get all the cool management features, we need to register it with something called the SQL Server IaaS agent extension. This is a critical step that gives us cloud-native, PaaS-like features on our simple virtual machine. We do this with just one more resource block. Resource: AzureM_SQL virtual machine SQL extension. Virtual machine ID equals AzureM Windows virtual machine.SQL VM.id. SQL license type equals pay-as-you-go. Auto patching, day of week equals Sunday. Maintenance window starting hour equals 2. Maintenance window duration in minutes equals 60. This AzureM SQL virtual machine resource is what turns our VM into a truly managed SQL VM. We link it directly to our VM using its ID and set the license to PAYG, or pay-as-you-go. Then we get to configure some really powerful features. The auto_patching block tells Azure to handle important Windows and SQL updates for us during a maintenance window we define. This extension automates a ton of work that a database admin would normally have to do by hand. With all our code in place, it's time to bring our infrastructure to life. The Terraform workflow is 3 simple steps: init, plan, and apply. First, open your terminal in the same folder as your .tf files and run terraform init. This command gets the project ready, downloads the Azure Provider plugin, and sets everything up. You only have to run this once for each project. Next, run terraform plan-out main.tf plan. Terraform will read your code and check with Azure to create an execution plan. It shows you exactly what it's going to create, change, or delete. Think of it as a dry run. It's your chance to review everything before it touches your actual cloud environment. Once you're happy with the plan, it's time to make it happen. Terraform apply main.tf plan. Terraform will now start creating the resources in the right order. This will take a few minutes, so feel free to grab a coffee. Once it's finished, Terraform will print out any outputs you defined. To see the results, just log in to the Azure portal. You'll find your new resource group, and inside it, the VM, the network interface, and everything else we defined. When you see the SQL Server virtual machine resource, you'll know the extension is working. You now have a fully functional SQL Server ready for your database. And there you have it, a fully functional SQL Server on an Azure VM deployed entirely with code in just a matter of minutes. We took what can be a complicated and error-prone process and turned it into a simple, repeatable, and automated workflow. So what's next? You could connect to this database from an application, or maybe check out more advanced features of the SQL IaaS agent extension, like integrating with Azure Key Vault. If you found this tutorial helpful, please hit that subscribe button and turn on notifications so you don't miss what's next. All the code from today's video is available in the GitHub repository linked right in the description. Thanks for watching, and I'll see you in the next one.